Hi, it's Charlie Zeiss from Stargate Pyramids and the Pyramid Science Foundation. Today's video is going to be about the discovery of 3D Phi scaling in land-based speed vehicles. We're going to be looking at a number of different topics today. Let me open up my screen and we'll show you what we're going to be talking about today. 3D Phi scaling geometry can be found in the design of high-speed land vehicles in a number of environments, including soapbox derby racing, Indy racing, Formula One racing, drag racing, sports car design, bullet trains, and land speed record vehicles. So the reason why you're going to find that geometry in so many places is due to the fact that the 76.345 degree 3D Phi scaling geometry helps to minimize drag, it improves speed and gas mileage, and it improves vehicular control. So let's get started. I'm going to open up this and we'll begin. The first segment, I found a few of these, and this was really the inspiration for this entire part of the documentary, is the soapbox derby racers. I remembered these images, so I went on Bing and I found them. So I'm going to show you three examples here. You can see that to begin with, to explain, 27.309 is the apex angle of the Phi scaling pyramid or Russian pyramid that has a 76.345 degree base or slant angle. So what you're going to see in a lot of these depictions today is the 27.309 and also another version of that, which is half that amount, which we'll discuss in a few minutes. But here's an example of the soapbox derby vintage racing car. Here's another one. And you can see these vintage cars all use this geometry because it helps to cut down on the wind resistance for the race. So this was a very popular and may still be a very popular geometry to use in soapbox derby racing. Now I want to move on to Indy racing. And what we're going to find is that this geometry is used in two different contexts. The first way I want to show it to you is from the front of these Indy racers, and you can see here that the center or core section of the vehicle itself has this 27.309 apex angle, which is reflective of 3D Phi scaling. So here's one example. Here's another example. You can see all of these cars use this. So three examples here of Indy type racing cars that have this 76.345 degree angle looking at it from the front of the car. Now we're going to look at it from the side view, and we're going to find that this very same angle shows up as well. Here's a side view of an Indy car, and you can see the 13.654 degree angle, which is half of the 27.309. You can say, well, why would they do that only on the top of the vehicle? You can see that in the front of the car, the underside is flat. And the reason for that is that they want to have the car focus, have the air pressure keeping the car down on the ground to control stability. But at the same time, they want to use the geometry that's going to maximize laminar flow, reduce friction and turbulence, and increase gas mileage as well. So you're going to see that in the side views of these cars. Now, the next two examples, you're going to see it not only in the front of the car, but in the rear of the car too, leading up to the back wheels. So they're trying to get the aerodynamics not only to improve speed, improve gas mileage, and so forth, but also to help keep the car on the ground. That's obviously the role of the spoilers as well, but it turns out that this geometric angle serves many functions in these cars. And here's yet a third example of another Indy racer where you see this geometry not only in the front of the car, but in the rear of the car, leading up to the rear wheels. Now we're going to move on to Formula One racing. You see the spoiler at the bottom here, but you're still going to see in the Formula One cars this 27.309 apex angle of 3D Phi scaling in the front of all of these Formula One racing vehicles as well. And similarly, you're going to see it in the front end of these racers as well. And you see an example here. There's a couple more. And now we'll move on to dragsters. And sure enough, you're going to find the very same thing in a lot of the dragster designs. So here's an example of a dragster with this geometry. Here's another one. And here's a stock car dragster where we see it not in the front, but in the back of the car. And we're going to see this angle in the back of the car in a lot of the sports cars that we find on our highways today. And so with that as a lead-in, we'll start looking at these cars. Once again, we're going to see that this geometry shows up in the back of these cars, and this helps with the aerodynamics. Actually improves speed and gas mileage and stability on the roads. So here we're going to see it in the rear half of these sports cars. For one thing, I think a lot of the hoods of these sports cars are similarly aerodynamically designed, but it's very hard to get a picture where I can actually measure the angle of the front of the car very easily. But here we have it in the Alfa Romeo with the Audi. Here's a Bentley Continental that has this geometry, BMW, Bugatti, Corvette, Dodge Viper, Ferrari, Enzo, F40, FXXK EVO. Here's a vintage 1965 Ford Mustang with this geometry in the back. Hennessy Venom. For those unfamiliar, Hennessy is a relatively new company based in suburban Houston that's producing these high-performance sports car vehicles. Here's a Jaguar with this geometry, Lamborghini, Lexus, Lotus, Lycan Hypersport. This is from the United Arab Emirates. Here's a McLaren 12C, a McLaren GT, Mercedes-Benz. This one actually has it on the front of the car, and you can see I can measure it fairly easily, so I've included that one in here as well. Here's a Renault Desire with this geometry, and finally we'll end this segment with the Rolls-Royce Wraith, which has this geometry as well. Now we're going to move on to bullet trains, and I've put in a picture of the bullet so you can see why these trains are named after bullets. It's because the front of these trains, in fact, are designed virtually identically to bullets. So here's a Japanese JR500 bullet train, and you can see once again, we're not going to see this geometry on the bottom side because they want to keep the train on the tracks. And so the aerodynamics are only used on the upside of the train, but we see the 13.654 angle, which again is half of the 27.309 that we have as the apex of the Phi scaling geometry. And here's another example of another bullet train with this geometry, and a third. So we see this bullet trains in Asia and in Europe. So this is a well-established piece of technology and knowledge, proving once again that this information is known to the engineers. They probably learn it through wind tunnels and not through sacred geometry, but this information is being withheld from all of us and is obviously of great value to all of us. Land speed record vehicles now. I decided to look these up, and we're going to see about 5 examples, I think. These are all different categories of vehicles that have set or attempted to set world land speed records for land-based vehicles. And this first one is called the Aussie Invader. And you can see at the front of it, its nose cone has the 27.309 geometry. I guess this craft is heavy enough that they're not worried about, liftoff or aerodynamics, keeping this out of control. But you can see that geometry is used in the nose cone. Here, this is another one called the Bloodhound. The Bloodhound, you can see, is flat on the bottom, where my cursor is now. So we're going to see the 13.654 geometry there. In the Fawcett LSR vehicle, we see the 27.309 geometry in the nose of the craft. And here we have the North American Eagle, which again has the full 27.309 geometry showing up in its nose. So we're going to finish off here with the Thrust SSC. And we can see here that it's not only on this nose cone sticking out in the front, but we'll see that same slant geometry in the intakes for the jet engines as well. So we see it once again in 2 different components of the aeronautics or of this vehicle. So I thank you for watching. I think this is yet another fascinating example of finding sacred geometry in our current technology. Please make sure to follow us on the Pyramid Science Foundation YouTube page. Please join us. And if you're interested in any of our pyramids, which are built on this technology and this geometry, go to stargatepyramids.com. We have a pyramid sale going on right now. Use logo 30 to receive 30% off of your pyramid products. And if you're interested in contacting me, please feel free to contact me at charlie@stargatepyramids.com or at 412-474-3481. And I thank you for watching, and you have a great day.